Alright, let's look at these examples. Okay, I will using this function also to explain the continuity at a point x equals to 1. Right? So I will giving you many examples later, so you have to understand. Alright, so we don't know the graph. Do you know how to sketch the graph? So if you know how to sketch the graph, you can see, is there the graph got breaking or not? Continuous or not continuous, right? So, but without drawing the graph, we can know by using the concept of limits and continuity. This chapter is all about limits and continuity. Limits is used to evaluate asymptote. Limits also used to determine the continuity of a function. There are many more. Okay, calculus is about limits. For your knowledge, calculus is about limits, the concept of limits. So now, let's say if you have definition for continuity, continuous at x equals to a. So the first condition, the limits of x approaching from the right and from the left must be the same. Must be the same. So if this must be the same, this one implies that the limit as x approaching a of fxl equals to L, which is exists value. So number 3 is the most important one. This is the one that determines whether it's continuous or not. If this limit exists, does not sure is not 100% sure that it's continuous. But with the value of fa also L, then they are continuous. Okay, you have to understand this concept and know how to state the definition for this. It's very important for your A-level exam or STPM exam. Alright, so let's look at this one. So first thing, follow the first one. So limits as x approaching 1 from the right, from the left. Evaluate this one first. From the right, from the left for this point. Now we're talking about 1, right? The boundary value here 1. So it means that from the right, 1 plus, you have 2x to the power of 2. So student, you substitute the 1, you're getting 2, right? So for x approaching 1 from the left, from the left. So from the left, so you were choosing, oh sorry, I have choosing, yeah, correct. Later. I think I already wrong choosing the function, alright, sorry. So this one, from the right, okay? From the right, greater than 1, right? Sorry, so greater than 1, so you will have 2x to the power of 2, alright? Oh, yeah, correct. Okay, I wrongly. So 1, so I have 2 times with 1 to the power of 2, so you have 2, right? Sorry, correct. So as you 1 plus means from the right, right? From the right. So greater than 1. So you're choosing 2x squared. So that's why you're getting 2. So from the left it is 1 less than 1. Alright, sorry. Just now I have also confused. So now you have less than 1. So means that less than 1 here. So 1 minus 3x. So you have 1 minus 3 multiply 1. So you have negative 2. Now you stop the video. You think. You pause the video. Is it continuous or not? Is it continuous? Look at the first condition. Is it continuous? From the right, you have 2. From the left, you have negative 2. The limit does not exist. Limit does not exist. Fx does not exist. The test already failed at 1. Fail. Right? Fail. These two fail. So don't need to go for the third condition. Ini dua pun sudah saring. Saringan dia dua ini pun sudah gagal. So tak payah cek yang ketiga. Kalau dua ini sama, contohnya ini dua, ini pun dua, baru kita cek yang ketiga. Alright? Kalau ketiga itu pun dua, baru kita kata continuous. Kalau dia bukan dua, kita kata not continuous. Alright? I state again. If let's say here is 2, here is also 2, then this 2 is pass. So then we go for the third one. If the third one is 2 also, the FA also 2, then we said, yes, this is continuous. So we don't need to go for finding the value of 1. Not a need to finding F1 now. Alright, but the F1 will be still negative 2, right? So the value is different. So limit does not exist. Limit does not exist means the graph is break. Okay, now the breaking of the graph. So it means that we can say that Fx is the most important thing. Discontinuous. Discontinuous. Right? We use the word discontinuous at x equals to 1. Right? So very simple. Okay, now if I sketching the graph, for this, you know, before you sketch, you already know. You already know what happened to the graph here. Very simple. So you look at this one. Before 1 and after 1 is 1 minus 3x. So you substitute 1, you're getting negative 2, right? Negative 1, 1, you're getting negative 2. So I put it as a solid circle because there is an equal here. There is a value. The F1 is negative 2, right? So the y-intercept, mx plus c, right? So it's passing through 1. So the graph may look like this way. Okay, sorry. The graph is a straight line. Look like this way. So later, 2x squared. 2x squared, the curve to be this way. Right? Can you see that? 2x squared. The graph will be this way, right? But we only want the graph after 1. So this one we don't want. Ini saya tak nak. I only want this part here. This part here. So during 1, you calculate from limit. During 1 plus 1, you're getting 2. So means that 2 is here, right? So the graph will going this way. So if you see that, this is a quadratic curve. If you look at this part here, pecah, break, right? Break, putus. Kita kata putus. So discontinuous here, right? Graphically, this is discontinuous here. Algebraically, I have proven, right? Okay, so I will go so details for this concept. Hope you understand. Okay, I will go for one more example in another video here.